All right, so we left off last period, just at the end, at the bell there, we were talking about example 2. We're moved on to example 3. They give us 2 charts to look at in example 3. In this particular graph, we're talking about colony, a growth colony, and they are measuring population versus time. So again, we have what's called a trend, okay, when we have our independent variable being time, and we're measuring another variable, it's called a trend. So there's just these values that I forgot to populate here. All right, so again, like all of these problems where we have a table of values, the first thing we want to try and do is identify what the pattern is or what's happening. Is there any big outliers in the pattern? Okay, so here we can see that our time in hours is increasing and our population seems to be also increasing, and it is throughout. Okay, same thing here. We have our time increasing in hours and our population is also increasing. Okay. One thing you might note between these two different graphs is the significant difference in the final population. Okay, so that should give you an idea of where the graph is going and the differences between those two particular graphs. All right, so it says compare the growth patterns of the 2 colonies. So if we take these values now and we plot them out, this one I've plotted out in yellow. This one's orange. Okay, so again, the accurate graph you can see is on page 348. But just to give you enough rough idea here, this graph here starts out very slowly. So it's a slow progression here in orange, and then it kind of tails off. So it's not really increasing much more. So it's a lot clearer on this particular example that we can't draw a line of best fit. We can only really draw a curve of best fit. Because if I draw a line like this, it's not going to be accurate for these points down here. Okay, so we need to draw this curve of best fit that looks something like this. Okay. Likewise for the yellow table of values, we can see that this graph now actually increases at a much faster rate. Okay. So we can see that there's a significant difference between these 2 sets of data, and that they are both quite evidently curves of best fit. Okay, you can't draw a line of best fit. See how if we were to use algebra as well on this, and we use this as one line, we wouldn't get an accurate representation of the data. So now, having drawn these 2 curves, we can interpolate or extrapolate any predictions that we need to make based on the data. Any questions? All right, so just in summary, sometimes a curve is a better option to use than 2 points. So I would say that this is the case for all curves of best fit. Okay, not sometimes, but always for curves of best fit, the graph line is better than 2 points. We can't use 2 points if it's a curve. Use interpolating or extrapolating to make predictions about the data. That's the same thing we can do with 6.2 with lines of data, but in this case we're using curves for best fit. And finally, sometimes you cannot draw a line or curve as data does not show a clear relationship. So I haven't shown that example in today's lesson, but we have talked about it several times before. Remember, if you have data that looks something like this, you can't draw any conclusions. You can't draw a curve, you cannot draw a line, because data is all over the place. If that's the case, then you can't show a relationship. You can't make any predictions based on them. Yeah?
So isn't that when you draw like one of those broken line graphs that go like that? Like up and down for those charts?
What, something like that?
Yeah.
No. Not sure what you're referring to. Any other questions? Okay, that's it. For the lesson.